Now moving on to our topics of determinants. From the previous videos, you would have there different methods on how we would solve determinants, and what we are going to have here would be some examples. Let's start our discussion with the 3 by 3 matrix. From the previous videos, you have seen that we do have different methods on how to work with determinants. One would be the general method, which would be employing the procedure of a cofactor method. In the cofactor method, we are going to work with our minors and cofactors, but we would have to add the values of the matrix. The first thing that you would have to do would be to check on how we are going to be making our solution shorter. Thereby, you would have to choose those elements that we are going to be using in this procedure. There would only be one row or one column that we are going to be using. So, for example, let's start with our determinant of matrix C, and I would be employing the third column. The third column would have a value of an element which is 0, which means that if I'm going to multiply this factor with its cofactor later on, then everything else would be simplified just as 0. So let's start. With the cofactor method, we would have to start off by placing our signs. And let's proceed. So, taking the first element of the third column, that would be 0, we would have to multiply our cofactors. Nevertheless, it is 0, that is why it's just like going to be simplified as 0. The next element would be negative 5. This would have to be multiplied by our cofactor, which would give us our elements 4, 7, 2, and 1. The third term would be with positive 6. So taking our cofactors, or the minors, we would have 4, 7, 5, and 8. From this equation, we can thereby use our Sarrus method or butterfly method in order for us to simplify our 2 by 2 matrix. So, this would be 0, minus 5, with the determinant of 4, minus 14, giving us minus 10, plus 6, times the determinant of 32 minus 35, or that would be negative 3. So simplifying, we would have here positive 50 minus 18, giving us the value of 32 for the determinant of matrix C. How about instead of taking the third column, we are going to use the first row? Still, it would have the 0, which would shorten our solution. So again, let's start with interchanging signs, and then continue with our determinant of C. So starting with our first element, we're going to have positive 4 with a cofactor, or the minors 8 and 5, 1 and 6. Then work with negative 7 and minors. Moving on to our second column, giving us the values of 5 and 5 with 2 and 6. Then the third one would still be a 0. So we are only going to work with two terms. So simplifying, we would have 4 with the determinant 48 minus 5 which would be 43 less 7 and the determinant of 30 minus 10 giving us 20. Now let's work and simplify these values. So 4 times 43 is taken as 172. 7 times 20 would be 140, giving us the value of the determinant still as 32. Just in case we would like to work on some column or some row without 0. So let's choose the third row. Again, place our interchanging signs and then move on with our determinant. Determinant of C this time would be positive 2 with our determinant or cofactors given as 7 and 0, then 8 and 5. This would be followed by a negative 1 with its determinants or cofactors taken as 4 and 0, then 5 and 5. And lastly, move on to eliminate our third column, thereby having our factors for positive 6 with 4 and 7, then 5 and 8. Let's simplify our equation. This would be 2 multiplied by 35 minus 0 would remain as 35. Less 1 of taken as 20 minus 0, still going to be 20. Plus 6 times 32 minus 35 or negative 3. So simplifying, we would have here 70 minus 20 minus 18 and still gives us the answer of 32. Next, a lot shorter method is what we call the butterfly method. In this method, we are just going to be weaving our way through the diagonals, working with the elements. So let's have our determinant of matrix C, having the values let's just make it bigger. The first one would be for us to check on our positives. The positives would be diagonals going downwards. So starting from our top left, it would go down to the bottom right. That would be 4 times 8 times 6. Again, it's a positive, so use plus. 7 times 5 times 2. And lastly, we would have 0 times 1 times 5, or let's just simply have it as 0. Computing, we would have 4 times 8 times 6 plus 7 times 5 times 2, giving us the value of 262 for the positives. Next, we are going to work with the negatives. The negatives would still be the same diagonal lines, but this time it would be the ones going upwards from your bottom left going to your upper right. So in this case, since they are negatives, we are going to use your subtraction or your negative sign. 2 times 8 times 0 would still be 0 or negative 0. 7 times 5 times 6. So minus 7 times 5 times 6. Another minus, that would be for 4 times 1 times 5. So simplifying our values, 7 times 5 times 6 and 4 times 5, giving us 230. So if we are going to coin these two, the positives less the negatives, we would have the answer still the same as 32. The Sarrus method would be our second shortcut method, which is just modifying our butterfly method. So if we do have our matrix 4, 7, 0, 5, 8, 5, and 2, 1, 6, in order for us not to be weaving our diagonals, we are just going to mirror the two other, or that would be the first and the second columns of our matrix, having them still the same, but would be simplifying our diagonals. And then, again, we are going to take our positives. This time, there wouldn't be any interweaving since we have reflected the two other columns. So we would still have 4, 8, and 6 for the first diagonal, plus 7 times 5 times 2 on the second, and again 0 plus 5 plus 1, or 0. And this would still be computed as 262. Next, take our negatives. The negatives would still be the same, coming from your lower left going to our upper right. So this would be 2 times 8 times 0 would still be 0. Less, since they are negatives, 1 times 5 times 4. And another 6 times 5 times 7. So simplifying, we would still arrive at the same value of 230. And again, positives less negatives would give us the answer of 32. Now, how about working with the bigger size determinants or matrices? That would be not with the standard 3 by 3, but probably having 4 by 4, 5 by 5, and so forth. We can still work on them by working with our cofactor method. The thing is, we would need to reduce these matrices into the 3 by 3 matrix. If we are going to denote our example matrix as matrix A, then the first thing that we are going to do would be to choose a row or a column which would give us the shortest solution. In this case, since you would notice that for row 2, there would be 2 zeros, then I would be choosing row 2. Again, start off with your cofactor method, distributing your interchanging signs. Then work with our determinant. So determinant A would be taken as, the first one would be 0. Then next would be positive 5 or plus 5. The minors inside this cofactor would be taken as, eliminating our row and column, that would be taken as 1, 2, 3, 7, 2, 1, and 4, 5, and 1. Moving on to the next, we would still have there negative 0. So, taking on the fourth term, we have positive 2 with the determinants 1, 2, and 3, 2, 3, and 0, and 7, 2, and 1. Then this would be as short as having only 2 terms. Let's simplify our determinant. So we would have here 5. Again, either you would like to work on another cofactor method in order for us to break down our 3 by 3, or use our Sarrus or your butterfly method since we are already working with 3 by 3. Let's have the shorter one. So if we are going to use our butterfly method, then this would be 1 times 2 times 1 would be 2. 2 times 1 times 4 would be 8. And 3 times 7 times 5 would be 105. Now take our negatives. 4 times 2 times 3 is taken as 24. 2 times 7 times 1 would be 14. And 1 times 5 times 1 would be 5. And that would be for the first term. Then move on to the second. 2 times 1 times 3 times 1 would be 3. Plus 2 times 0 times 7 would still be 0. And take 3 times 2 times 2, or that would be 12. And again, work with our negatives. 7 times 3 times 3 is 63. Minus 1 times 2 times 0 would be 0. And 2 times 2 times 1 would be 4. So simplifying, we would have 5 multiplied by 2 plus 8 plus 105 less 24 minus 14 and minus 5, giving us 72. This would be added with 2 times 3 plus 12 minus 63 minus 4, giving us minus 52. So let's see. 5 times 72 plus 2 times negative 52 would be giving us 256. And that would be the determinant of matrix A. How about we are going to work with the same cofactor method, but instead of using the butterfly or the Sarrus method, we are going to work all the way with the cofactor until 2 by 2 matrix. This time, let's use the first row. Again, we are going to start with distributing our signs. And start with the determinant. So for the first element, we would be having 1 or positive 1 with the remaining elements 5, 3, 0, 0, 2, 1, and 2, 5, 1. Move on to the next. The next is 0. So we can have it as minus 0. And that would make our solution shorter. Following it with our plus 2. With the cofactors having 2, 5, 0, 701, and 421. And lastly, we have -3. The remaining elements would be 253, 702, 425. Instead of using our Sarrus method, we are going to be working on the second procedure, still with our cofactor method. And that would be like with our 1. This time, we are going to choose again a row or a column. So let's choose the first row for the first term. Place your signs, then move on to our determinant. 5 with our remaining minors, 2, 1, 5, 1. Moving on to the next, we get 3 or -3, and the remaining 0, 1, 2, 1. And for the third, you would notice that it's going to be multiplied by 0, which would mean that we already have our first term. Now try the third term. Again, let's work with the first row. So start with the first element. That would be 2 multiplied by 0, 1, 2, 1. Now take the second element, which would be given as -5. By the way, don't forget that this would have these signs. That's why I'm using -5. The cofactors being 7, 1, 4, 1 for the minors. And lastly, again, I do have 0. So this would be for the second term. Last, we have -3. In this case, let us take the second row. So negative, 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 last negative. Start with the first element, then that would be -7, leaving us with 5, 3, 2, 5. Moving on to the second element, which is 0, giving us 0. The third one is -2, with the minors, 2, 5, 4, and 2. This time we are going to work with our method. Since we would only have like 2 by 2, I mean working with the butterfly method, 2 by 2 matrix would already be good enough. So 1, 5 times 2 minus 5 minus 3 times 0 minus 2. Plus 2 times 2 of 0 minus 2 less 5 with 7 minus 4, or that would be 3. Moving on to the last term. 3 with negative 7 of 25 minus 6 minus 2 of 4 minus 20. Okay, so simplifying, 1 of negative 15 minus 3 minus 2 would be plus 6. Plus 2 with negative 4 minus 15. Less 3 with 7 times 19, giving us 133, and that is negative. Minus or plus 32. Simplifying our values, nine plus 2 times 19 and this is supposed to be a negative. Then take 133 less 32 and multiply to have positive 303. Now, simplifying further, 303 less 9 less 39 would give us, oh sorry, this is 38, would give us 256. And we still have the same answer, just like what we solved earlier. The fourth method in finding determinants of matrices, especially for bigger matrices, would be Chio's pivotal condensation method. Unlike the cofactor method, wherein we are to choose a row or a column with as many zeros as possible, for pivotal condensation method, we are going to look for a pivotal element. That pivotal element would have to have a value of 1. In our example, we would have 3 options. We would have this one, another one, and the last one. Let us choose the first option. So, with our pivot element, we would have to consider its row and column. Let's start with our determinant. Covering the pivotal column and pivotal row, we are going to have the values 5, 0, 2, 3, 2, 5, and 0, 1, and 1. The next thing to consider would be reflecting the column and the row of these elements. That would be, for 5, we would have there 0 and 2. These values would have to be deducted, or that would be 0 times 2. Next, for 0, you would have 0 and 7, or 0 minus 0 times 7. Lastly, you would have 0 and 4. So 0 and 4. The next thing for us to consider would be for the next column. So this would have 2 and 2. So minus 2 times 2. Next would be 2 times 7. Minus 2 times 7, and 2 times 4, minus 2 times 4. Lastly, for our third column, then we would have minus 3 times 2, minus 3 times 7, and minus 3 times 4. And that would complete our matrix. The next thing that you would consider, just like what we did with our cofactor, we would have to multiply our value of -1 as a scalar, and we are going to have this raised according to what pivotal element we used. In our case, we have A11. So we are going to raise -1 with 1 plus 1, and taking -1 squared would just simply be +1. So let's simplify our matrix. We would have 5, 0, and 2. Next, 3 minus 4 would be -1, 2 minus -14 would be -12, and 5 minus 8 is -3. Last column, 0 minus 6 would be -6, 1 minus 21 would be -20, and 1 minus 12 would be -11. In case we are going to use our Sarrus method this time, so let's reflect our two rows or two columns. So 5, 0, 2, -1, -12, and -3. Then take our positives. In this case, we would have 5 times -12 times -11 plus -1 times -20 times 2 and 0. In this case, we would have 5 times 12 times 11 plus 40, giving us 700. Next, let's check on our negatives. So first, we would have 2 times -12 and -6. Then we would have -3 times -20 times 5. And lastly, we would also have 0. So simplifying, 2 times 12 times 6 plus 3 times 20 times 5 would be -444. Thus, 700 less 444 would give us the answer of 256, just the same. In case we would like to take this 1 as our pivotal element, so let's have the third row and the fourth column covered. So the determinant of A would be taken as -1. Check on the location of our pivotal element. We do have 1, 2, 3 plus 1, 2, 3, 4. Then work with our determinant. Now let's reflect our values. So for 1, it would have -7 times 3 For 2 would be 7 times 0. And for 4, we would have minus 7 times 1. For the second column, we would have 0, taking it 0 and 3. Minus 0 times 3. 5 would have 0 and 0. And 2 would have 0 and 1. Let's have our third column. 2 would get 2 and 3. So minus 2 times 3. 3 would have 2 and 0. 5 would be reflecting 2 and 1. So simplifying our matrix, we would have negative 1 of 1 minus 21 would be negative 20. 2 minus 0 would be 2. 4 minus 7 is negative 3. 0 minus 0 would give us 0. 5 minus 0 is still 5. 2 minus 0 would still be 2. For the third column, we have 2 minus 6 give us negative 4. 3 minus 0 would be 3. Then 5 minus 2 gives us 3. Let's reflect our two columns. And take our positives. That would give us negative 20 times 5 times 3 plus 0 plus negative 4 times 2 times 2. So taking our values, we would have negative 20 times 5 times 3 minus 4 times 2 times 2, giving us negative 316. Now let's work with our negatives. And that would be negative of negative 3 times 5 times negative 4 plus 2 times 3 times negative 20 plus 0. Taking our values, negative 3 times 5 times negative 4 plus 2 times 3 times negative 20. This would be minus 60, and taking our negative sign would be positive 60. So 316 less 60, we would have 256 as a negative. Now, do not forget that we still have our multiplier from the scalar, which would be taken as the determinant of A is negative 1 of negative 256, which would still be taken as positive 256. Let's take this case. We had said that for Chio's pivotal condensation method, we are supposed to look for the element valued 1 to make it as our pivot element. However, in our matrix, let's say matrix P, we do not have any value 1. What we would do would be to look for an element wherein we are going to convert that element with its column or its row into 1. Let's choose the last row. In this case, if we are going to extract 2, we would have the same elements for the other columns or other rows. And work with our last row. So that would be 2 divided by 2 is 1. Then we would have this as 5 halves, and this would be 2. Now we can use this as our pivot. Thus, we are going to be eliminating our first column and our last row. So the determinant of B would be taken as 2 of -1, and again, take the index of our pivot element. We have 1, 2, 3, 4 rows and the first column. So this would be taken as raised to 4 plus 1, or that would be raised to 5. Let's have our remaining elements. 2, 3, 5, 0, 3, 2, and 3, 2, 3. Then, we're going to deduct our reflections. So for 2, we would have -1 times 3. 3 would be taken as 1 times 4. And 5 would be taken as 1 times 2. Then for 0, we would have this as -3 and 5 halves. 3 would have 4 and 5 halves. Then 2 would be taken as -2 and 5 halves. Thirdly, the first element of the third column would have -3 times 2. The next would have -4 times 2. And last, we would have -2 times 2. Now let's simplify our matrix. So 2 times -1 to the 5th power would just be -2. Then we will take this as 2 times minus 3 would be -1, 3 minus 4, then 5 minus 2 would be -3. Oh, +3, sorry. Next one, 0 minus 3 times 5 halves would be taken as 15 halves, negative. Then 3 minus 4 times 5 halves, canceling these two. So you would have 3 minus 10 would give us 7, -7. Then canceling 2 and 2, we would have 2 minus 5, giving us -3. Then next, 3 minus 6 would give us negative 3. 2 minus 8 is negative 6. And 3 minus 4 is negative 1. Let's have Sarrus reflection. Then take our positives. That would be negative 1 times negative 7 times negative 1 plus negative 15/2 times negative 6 times 3, and we would have negative 3 times negative 1 times negative 3. So computing, we would have negative 7 plus negative 15/2 times negative 6 times 3 plus negative 3 times negative 3. This would turn out to be 119. Moving on to our negatives. Which would turn out as 3 minus 7 times 3 times negative 7 times negative 3, with the other negative 3 times negative 6 and negative 1. Let me clean that up. And lastly, we would have negative 1 times negative 1 times negative 15/2. Let's take this as our negative. That would be 3 times negative 7 times negative 3 plus negative 3 times negative 6 and another plus of negative 15 all over 2. This would give us 75/2. So 119 minus 75/2 would be given as 163 all over 2. Now, we're going to plug in what we have outside of our matrix. That would be given as negative 2. Because it would be like 2 times negative 1 raised to the 5th power, negative 2. So canceling this, we would have our determinant of matrix P as negative 163.